Hi there, Nicole. This is the rest of problem 5.1. The normalization constant. Now, the normalization constant is the n. So here's the psi. It is the n sine alpha phi. This is the n which forces the following to be true. It forces the probability for the particle to be anywhere on this circle to be 100%. They've told us that that the angle phi defines where the particle is, but if the n it makes this wave function usable for probability. So it scales this wave function up or down so that the total probability for all possible locations of phi of the particle is going to be 100% or 1. And to express that in math, we go for the entire circle, the wave function times the wave function conjugate, and then there's only one variable here, it's d phi, it's phi, right, equals 1, all right? So that's the job of the n, to allow this to be true. So this conjugate just means if there is an imaginary number, an I inside the psi, we'll just change the sign of the I and then copy down the rest of the function. So it's the same thing as this with the I signs changed, but here there is no I, so we don't have to worry about that. Now, what are the limits of integration here? It's all over this entire circle. So that means phi goes from 0 to, that's right, 2 pi. All right, so let's do that. So this is going to be the integral from 0 to 2 pi of n sine alpha phi times n sine alpha phi d phi. And that is equal to, I'm just going to take these n's out because they are constants, n squared times 0 to 2 pi. This is sine squared alpha phi d phi. So they have given us a hint in the homework. They have said that sine squared of something equals 1/2 1 minus cosine 2 times that something. So let's use that hint, shall we? So this equals n squared, an integral from 0 to 2 pi. Now we're going to change this to 1/2 1 minus cosine 2 of whatever you've got here, which is going to be alpha phi, and the d phi. All right. I don't really need these parentheses on the outside, I guess. Well, maybe I do. I'm not sure. So since this is 1/2 times the whole thing, I'm just going to move this 1/2 over there with the n squared. All right. So now I have n squared. So I'm gonna actually distribute this guy around here so I could have two separate integrals. So n squared d phi from 0 to 2 pi minus n squared over 2 from 0 to 2 pi. And what's this guy? This is cos 2 alpha phi d phi. Cos 2 alpha phi d phi. Oh, now this is nice because I know that the integral of cosine is sine. Can I go down here? Oh, nice. I have some more room. All right, so this first guy from 0 to 2 pi, so this first guy, right? So it's n squared over 2 times phi from 0 to 2 pi, right? So that is obviously 0 times anything is 0, but 2 pi times n squared over 2 is n squared times pi, because the 2's cancel out, right? So this is going to end up being n squared times pi, just for future reference. And now this stuff, this is going to be n squared over 2. Now how do we integrate? Well, we've just said that. So I'm going to need a little bit of a chain rule action here, right? We're going to do the u substitution. So let's let u equal 2 alpha phi, right? So then the du will be equal to so du d phi, du d phi will be equal to just 2 alpha, right? So that means that d phi will be equal to 1 over 2 alpha du. Wait, flip this over, d phi over du. Flip this over, yes, so times du, times du, like that, okay? So with that u substitution, I do the integral here, and this is now cosine of u, and then d phi is du over 2 alpha. So du over 2 alpha. And I'm going to put this over 2 alpha outside right there, right? So this is going to be, remember we said that this is going to be n squared times pi, all right? That's cool. And then minus n squared over, now with this 2 alpha out there, it's going to be n squared over 4 alpha, right? And that's going to be cosine u du, all right? And then, let me get a new page here. This is my first time using, oh, okay, that's good. I like it to be black, so I'm going to try to make this black. Okay, that's good. Then, okay, so what was that other one? Yeah, so we ended at n squared pi minus this stuff, right? So we ended at n squared pi minus integral of cosine u du, except over here it was n squared over 4 alpha. Is that where we ended? Is that where we ended? Yeah, that's good. Okay, now that just equals n squared pi minus n squared over 4 alpha times sine of u, all right? But there are some limits of integration here, aren't there? Right? So let's convert the u back into the phi's, right? So what did we say that the u was? We said the u was 2 alpha phi, all right? So this is going to be equal to n squared pi minus n squared over 4 alpha times sine of 2 alpha phi, right? From, sorry, it's kind of messy there. Right. 2 alpha phi integrated from, what was it? It was from 0 to 2 pi. 0 to 2 pi, yes, 0 to 2 pi. Oh, hey, guess what? When you integrate a sine function from 0 to 2 pi, well, we'll see in a moment here. So, so this is going to be equal to, all this stuff is the same, except for this is going to be sine 2 alpha 2 pi minus the sine of 2 alpha 0. Now, the sine, so 0 times anything is 0. So this is sine of 0. You remember on the unit circle, 0 is right here. Sine is the y coordinate, so that's 0. So this is just 0. Now, what's sine of 2 pi, of 4 pi? 4 pi times alpha. We just got done seeing that alpha is an integer, right? So sine of 4 pi times an integer is still going to be right here, right here, right here. You could be backwards, it could be a negative integer, anything. So that means this is also 0. All this is 0, except for this guy right here, all right? So that leaves us with, wait, what are we saying? Oh yeah, so this has to all equal 1, right? We started with this whole, we didn't start, so this has to equal 1. Sorry about that. So this all has to equal 1. Yeah, we started right here. So the total probability is 100%, meaning this integral has to equal 1. So all this is equal to 1. So this is equal to 1. So 1 equals n squared pi. So then let me solve for n there. 1 over pi equals n squared. And so the square root of 1 over pi equals n. That's great. Yeah. Now, I know what you're thinking. You're thinking, hey, shouldn't it be plus or minus? Yeah, you know, technically in math, I think this is supposed to be plus or minus, but in science, there's no such thing as a negative probability, and so we don't care about the negative. We just care about the positive. I think before you square the function psi, This function psi might be called a probability density or something. Psi times something else is a probability density. So there's no such thing as a negative probability density. So we ignore the negative part. Just the positive is what we want, right? So that's the n. Thank you. Bye.